All right, so it says, how can you decide whether to add or subtract to eliminate a variable in a linear system? Explain your reasoning. Well, in order to eliminate, you need opposites of the same variable, right? So let me give you an example. What we look for, in other words, if we don't see this, then we have to do something else. So what we're looking for is like, and I'll write it in a different color. Maybe I'm looking for a positive 3x and a negative 3x. Or maybe I'm looking for 4y and a negative 4y in two separate equations, of course. All right. So when I look at the two equations, what I'm looking for is either the x's or y's to be opposite coefficients, and then when I add them up, they equal 0, right? So that's the other thing I want to think or explain. So over here, just write 3x minus 3x equals 0, and then or 4y minus 4y equals 0. And so those variables are eliminated. X and y are eliminated. Now, this isn't always the case. So substitution works well when something is solved for x, or there's a y by itself. It has a leading coefficient. Well, I shouldn't say leading. It has a coefficient of positive 1. That's something that we can easily solve and substitute. Elimination, adding and subtracting two equations, works well when you can have an opposite. Okay? Sometimes you'll have a 3x and a 3x, and then you would subtract one of the equations. Okay? So now let's do problems 8, 9, and 10 and see how we feel about this. So for 8, what we need to do is we need to take one of these and subtract it from the other. So if I say 6, I'm going to zoom in too, so I have lots of space. Oh man, that's really zoomed in, isn't it? So if I take 6x minus 3y, now when I subtract this whole thing, remember that it's like multiplying by negative 1. So this whole next equation, you multiply by negative 1. And really what it does is it reverses the sign. If it's a positive value, then it becomes negative. If it's a negative value, it becomes positive. Right? So negative 1 times 6x is negative 6x. Negative 1 times positive 8y becomes negative 8y. Negative 1 times negative 16 becomes a positive 16. When I add those up, I get 0, right? 0x, but I don't need to write the 0 down. This becomes negative 11y is equal to 22. Divide by negative 11 on both sides, and I get y equals negative 2. Yes. What is it that you don't get?
Oh wait, never mind, I do get it. So like what you did was, did you add 3 to 8 and then?
Yep, we're vertically. So yeah, okay. Let me go back over it. Okay. Yeah. So basically, 6x and 6x are not opposites as they stand.
They just cancel, right?
Well, I need to make this bottom one a negative 6x. So to make it a negative 6x, I'm going to multiply by negative 1. But remember, with an equation, when you multiply by a number, you have to multiply it by every term.
Yeah.
So I'm going to multiply this by this, I'm going to multiply negative 1 by this, and I'm going to multiply negative 1 by this. When I do that, so this is like the first equation, and the second equation becomes this after I multiply by a negative 1. From there, I just add them up. 6x plus negative 6x is 0. Negative 3y plus negative 8y becomes negative 11y. 6 plus 16 becomes 22. Was that your question? Yeah. Yep. And that's the process. And then what happens is we eliminate the x. I get some numbers and a y, and then I could solve for y. And that's just algebra. And I find out that y equals negative 2. We're done, right? No. What do we got to do? Yeah, we have to find x. Very good. So to find x, it doesn't matter which equation I use. I'm going to use the first equation, and I'm going to say 6x minus 3 times y. But what's y equal? Negative 2 equals 6. So what I'm doing is I'm taking this first equation, and I'm rewriting the equation. The only thing I'm doing different is wherever there was a y in this equation, I'm putting in y equals negative 2. So now it's just algebra. I have a bunch of numbers and the variable x. So this becomes 6x. Negative 3 times negative 2 is positive 6. Very good. If you're not real good with positive and negatives, grab those calculators. So then I subtract 6 from both sides. I drooled a little bit there. That was funny. So I get 6x. What's 6 minus 6? 0. Can 0 be the answer? Yeah, it can. 0 is a number just like all the other numbers. So I'm going to divide by 6, divide by 6. What's 0 divided by 6? 0. So that's my x value. So now according to all of this, my answer is 0, comma, negative 2, because this is my x value and this is my y value. How can I double check that? I can plug it into Desmos. So I'm going to pull up Desmos on another screen over here, plug in the equations, and bring it back. And so if I graph this in Desmos, how do I verify that my algebra is right? What am I looking for when I graph these two equations? Huh? What am I looking for when I graph these two equations? What does graphing these equations do to help me figure out this is the solution? Are you guys not awake?
No.
No? You don't have what? So generally, when you say something and somebody says what, that means they can't hear you. So then you could repeat what you said, but louder. Let me demonstrate. This is what just happened to me. I'm going to say something. Now you say what?
What?
Then I go. Exactly. So anyways, what we're looking for, sleepyheads, is we're looking for where the two lines intersect. Okay? That's what we're looking for. Hey, look. Guess where they intersect? At 0, comma, negative 2. Let's take a picture of that. Plug it into our handy-dandy notes here. And that just kind of verifies that's going to be humongous. We'll zoom fit. Yeah. It's going to be humongous. That's really tiny. Let's try to make this a little bigger here. So that's where it crosses, okay? It crosses at 0, comma, negative 2. Does that make sense? Let's do the next one. Let's try to, I'm going to go a little faster on this one. Which ones should cancel out on number 9? 3 y's, right? Now, I have to make one of those an opposite. So how do I make one of those 3 y's an opposite? Yep. Somebody said switch it to a negative. The other one says multiply by a -1. They're both correct. So which one do we want to switch? The first one or the bottom one? Let's do the first one just for the fun of it. It really doesn't matter. So when I multiply this by -1, I need to multiply all three of these by -1. In other words, this becomes -4x minus 3y equals -19. And then the rest of these are just the same. So this is positive 6x plus 3y. My x's and y's look very similar. And then we just add them up. What's 6x minus 4? X? 2x. These cancel. And now what's 33 minus 19?
Oh, wait.
Well, so here's the thing, if you don't know, we could just plug it into the calculator, right? I think it's 14, right? Let's see. I'm going to say, let me move this over here. 33 minus 19, yeah, 14. So 14. Now, Mr. Adams could do that in his head. Why do you think I did the calculator?
Just to make sure.
Just to make sure. Plus, it's okay to use a calculator at this stage of the game. I know when you guys are in elementary school, your teachers say, use mental math, and they are 100% right.
Well, you see, this is harder to remember.
Yeah, this is harder, so it's okay to use the calculator. Anyways, are we done? No, what do we got to do? Plug it into one of these. So I'm going to take the second equation, this one right here, and wherever there's an x, so it's 6 times x, I'm going to plug in a 7, plus 3y equals 33. So what I'm doing is I'm taking the second equation, this one right here, and I'm rewriting it, except wherever there's an x, I'm plugging in a 7 for x. Okay? Then I have a y and a bunch of numbers. 6 times 7 is 42, plus 3y equals 33. I'm going to subtract 42 from both sides. This becomes 3y equals 33 minus 42. Let's see what that is. So 33 minus 42, -9. Divide both sides by 3. Now, here's another thing that students will make a little bit of a mistake on. They'll say it's 3. And then they'll go, well, wait, no, it's -3. And they can't remember the rules. Use your calculator. -9 divided by 3 is, whoops, -9 divided by 3. Why does it keep saying answer? Oh, -9 divided by 3. There we go. I got it eventually. It's -3. I was saying the answer. You guys, anyways, y equals -3. So that means that my solution to this set is 7, -3. How could I verify that? Yeah, I'm going to graph them on the graphing calculator. I'm going to move this over here so I can look at the screen. And then what am I looking for? What does this 7, -3 represent on the graph? It's not the y-intercept. I heard somebody say y-intercept. Nope, that's a different thing. It's an intersection for sure, but it's just where the two graphs intersect. Yeah, they should cross at 7, -3. Now, an intercept is an intersection, but that's with an axis. So when we say x-intercept, y-intercept, we're saying where does this cross the x-axis or the y-axis? All right, look what I have here. Well, guess where it crosses? What? Pretty sneaky, sis. Don't say that again. You guys never heard of that commercial before?
No.
That commercial on 20 years ago.
That's probably closer to 30 years ago. It might even be 40 years ago. We'll Google it after this.
Wait, what is the commercial?
I can't remember. It was a commercial that they used to have on TV, and it was about, there were two little kids, and the one kid would say, "Pretty sneaky, sis." It was a thing for a while. Anyways, any questions on this one? All right, what I want you guys to do now is I want you to try to do problem number 10 on your own. I'm going to give you a few minutes to do that. Okay, try to do it on your own, and let's see what you get for an answer.